Okay, there was a time when mathematicians decided that they were kind of sick of writing the radical sign. They'd rather figure out some way to represent radicals as exponents. So let's take a look at the simplest one. We're going to take square root of a. Well, we know that the square root of a times the square root of a equals a. I mean, that's the definition of square roots, right? Okay. That times itself gives you that. Okay. So they decided, well, let's pretend that there was some kind of exponent that means the same thing. Well, then if you multiply those together, you would get a. So we're pretending that there is this exponent k that represents square roots. So I'm just let k mean square roots. Okay, so we're just picking a variable just randomly that means square roots. Now, I know my exponent rules. And when I multiply two things that have the same base, I add the exponents. So that's going to be a to the 2k equals a. And I also know that anything by itself really has an exponent of 1. Now, let's really think about this. If this is truly an equation, and those bases are the same, then those exponents have to be equal. And that's really a big concept here that we'll be using a lot. Bases are the same, and this is an equation. Therefore, the exponents must be equal. This means that k is 1/2. So what this is telling me is that the square root of 36 can be rewritten as 36 to the 1/2. Well, that just doesn't even make sense. That's silly. Or maybe not. Let me take a second and get my calculator. And let's test this theory. Let's see if that really does work. 36 to the 1/2. It is 6. It does find the square root. So it does work. So square root of 64, I can represent that as 64 to the 1/2, and let's see if we get the same thing. We get 8. It is taking the square root. So let's think. How could we represent the cube root of something? Well, square root was 1/2. I'm going to go crazy on a limb and just say, what about to the 1/3? 27 to the 1/3. Better give me 3, huh? It does. Hey, that's even faster than sitting there and making a little tree and trying to figure out what the cube root of 27 is. Even fourth roots, 625 to the 1/4. And when I do that in my calculator, I again get a nice answer. So this is beautiful. But what if I still want to represent as a fraction, but I had a square root or cube root or whatever, and then an exponent on the outside? Well, that's okay. That's not a big deal. I know that the square root now can be rewritten as to the 1/2 power, and that's being cubed. Power to a power, 2 in the sky, you multiply. 1/2 times 3 gives me 3/2. Now, why is that helpful? Well, I can go the other way. What if I had something to the 3/2 power? Now I know what that means. That denominator tells me what kind of root I have. It tells me that I'm supposed to take the square root of 9 and then cube it. That's where that 3 comes from. Square root of 9 is 3. 3 cubed is 27. What about something even scarier? All right, first off, let's remember what the negative exponent means. It means 1 over that to the positive exponent. Now we can really break it apart. The 5 is in the denominator. That tells me the kind of root I have. It means the 5th root of 32, and then square it. I know the 5th root of 32, that's 2. So now I have 1 over 2 squared, which is 1/4. Let's see if that works. Now remember, you don't always have a calculator, but we're going to use it right now to check. Gave me 0.25, which is 1/4. All right, let's look at some more examples. And working with, these are called rational exponents. Now, why are they called rational exponents? Well, rational numbers are numbers that can be represented in fractions. So rational exponents just means I have fractions in the exponents. All the rules stay the same. If I'm multiplying two things, they have the same base, then I'm going to add my exponents. So I'm going to take 1/2 plus 1/4. Now remember, you want to find common denominators. So that's 2/4 plus 1/4. That's 5 to the 3/4. Everything works just like your other rules of exponents. So let's take one of the rules. This one is the rule of product to a power. Now the reason I'm using that rule here is because the bases are not the same. I can't multiply those together. But what I can do is, since we have a product all squared, that really means that I have 8 to the 1/2 squared and 5 to the 1/3 squared. Power to a power, 2 in the sky you multiply, that's going to give me 8. And this is going to give me times 5 to the 2/3. Let's get a little bit crazier. 2 to the 4th times 3 to the 4th to the negative 1/4. Again, these bases don't match, but since it's a product to a power up here, I can apply it to both. That's going to give me 2 to the 4th to the negative 1/4 and 3 to the 4th to the negative 1/4. Power to a power, 4 times negative 1/4 is going to give me 2 to the negative 1. Well, that's going to give me 3 to the negative 1. Remember what the negative exponents mean. That means I've got 1/2 and 1/3, which give me 1/6. Now, could I have kind of used that rule about the product of a power backwards and realized that these were both to the 4th power? So that could have been 6 to the 4th to the negative 1/4, or 6 to the negative 1, and still gotten to 1/6? I could have, but I just didn't happen to see it that way at the moment. Next one. I've got 7 to the 2/3 divided by 7 to the 3/4. Now remember our division. When we're dividing two things and they're the same base, we're going to subtract our exponents. So I'm going to take 2/3 minus 3/4. So we need to have that common denominator to subtract fractions. So let's use 12. Okay? So if I'm going to use 12, I need to multiply the numerator and denominator by 4. That's 8/12. Numerator and denominator by 3. That's 9/12. 8/12 minus 9/12 is going to give me 7 to the negative 1/12, or 1 over 7 to the 1/12. Now, I do want to remind you, what does that mean? That 12 in that denominator. Well, that's the 12th root of 7. It's a little bit easier to work with as a fraction. All right, what about a little bit more complicated? What if we have a lot of stuff going on? Are our rules really going to change? No. We still work with everything like we used to. So I would take a moment and look at my numbers. I got 6 and 2, both divisible by 2, so that would give me a 3, and that'd be just 1. Let's see, negative exponents. Negative exponent moves to the top and becomes positive. This x by itself, that's really just a 1, right? Okay. Now, Or could I write it as 3/3? Would that be okay? I have 3/3 up here, 1/3 up here. 3/3 minus 1/3 leaves me with x to the 2/3. Now there's a 3 up there as well. Y to the half, there's nothing below. And there's nothing left in the denominator. That worked out pretty nicely. So all of your rules of exponents work the same way. We're just working with fractions, and that's where it's going to run into problems. A lot of you have trouble with fractions. But don't be scared of them. They're just numbers.